when you come to Ohio State, the first thing you do is you go to the freshman program, and all the engineers take the same freshman courses, and they're really good. In fact, I'm insanely jealous. I wish I'd had that when I was young, but no, we had rocks and bricks and stuff. But anyways, it's a very good freshman program, and what they do is they have all these labs, and so each lab, one lab it might be electrical lab, the next lab might be a mechanical lab, the next lab might be chemical engineering lab. So during that freshman year, you have lots of time to explore all the different things you want to do and see what floats your boat, and then you'll come to your senses and come to electrical engineering. Once you get into electrical engineering, we just scrapped our entire sophomore program. We had these older courses that had been around a while, and we just threw those out, and we took them, and we made this new sophomore sequence that is so cool. Oh, it is very cool. So they have iPads in the lab, and they have all these cool equipment. All brand new equipment, I might say. They got this special room that only sophomores can go in. Can I go in there? No, my card key won't open it. Sophomores can go in there, and in addition to all the labs, which is an open lab, so they can go in anytime they want and work on their projects, they also have a big screen TV so they can rewatch the lectures, and they can chat with each other, and on Friday nights they can watch movies, and they have a popcorn machine in there. I mean, this is not right. When I was young, did I mention rocks and bricks? So the sophomore program is really cool, and then once you get through that, then you've had sort of the basics, and then you start going out and taking all your technical electives, and we have like a bazillion technical electives. That's actually one of the advantages of coming to a big school like Ohio State, because we're so big, we have lots and lots of courses. You can take all kind of crazy stuff. You can take medical imaging, you can take the photonics lab, that's a good one. You can take lasers or fiber optics, you can take neural networks, communications, all kinds of things, wireless, antennas, all kind of stuff.
When I first came, I was nervous like most people about the size of the school, but it actually doesn't feel that big to me. I'm actually surprised by how small it feels, because really all your classes are going to be in one part of campus, so you'll just walk around there and you'll see the same people every day.
Reading and research are a really important part of my graduate work, so I've been so pleased with the professionalism and the support that I get from the university libraries. There's been maybe a handful of books or articles that I couldn't have obtained through them that I had to go to an interlibrary loan to get. And related to research, I think one of the really cool things that I'd like to shout out for is the Ohio Supercomputer Center, which has some of the world's most famous engineers working on creating a high-performance computing environment for researchers like me, as well as the Electro Science Lab to do the kind of research that I want to accomplish.
One of the big advantages of being at a huge research university like Ohio State is that there's a very broad range of research going on. So no matter what you're interested in, you can bet that there's somebody doing research on that topic. The faculty and the students are on the same page, and that their goal is to produce top-level research and top-level graduates. And a big part of that is the collaboration that goes on. This is very much an environment that fosters collaboration. Really, everybody, as I said, is on the same page here. We're all about putting out great research and innovation, and the faculty collaborates to that end.
So the ECE department here is a large department, very diverse. We have many different areas in which we do research. But one of the things that's different here is we have a very large and very active undergraduate population. You know, there's a lot of undergraduates that we not only teach in classes, but we also meet them as they do research projects and things like that.
I really like the ECE program because all of the professors really care about the students and want to see you succeed. And if you put the time in to go talk to them and introduce yourself, and they will really help you out. And you're not going to experience any of that, you know, you're just a number, you have 200 people in your class. All the classes are really small.
Well, I've always been interested since I was very young in technology and various aspects. At the beginning, actually, my major interest in college was microelectronics and VLSI design. But then I discovered the beauty of linear algebra and mathematics and decided to switch to systems theory, which was in my opinion, the perfect marriage between engineering and mathematics.
I've been told, if you want to save one person, become a doctor. If you want to save the world, become an engineer. Electrical was the specialization of engineering that appealed most to me, and I really like circuits, and I like what electrical engineers do.
Since I became an electrical engineer, I find this really fun because you get to invent stuff and you get to learn all these cool things, and when new technology happens, you're the first one to understand it, or you could be the one to invent it. So it's lots of fun. I like going in the lab and building things and making things and inventing stuff.
They're really caring towards the students and want to see you succeed. They'll help you out however they can, and being one of those people that they see as active in the school, they're going to put extra attention into you.
Everybody here, both my graduate student colleagues as well as the mentors, the postdocs, and the advisors, are extremely knowledgeable as well as humble people, and they're very generous with their time, and it's been absolutely great working with such a great group of people.
The ECE faculty are very approachable, very friendly. I've had really enriching discussions with them in class or in the office hours, or even I can catch them across on the hallway and have a discussion. The class sizes are very small, so it allows you to have one-to-one interaction with the professors.
I work in radar signal processing, and my goal is to create algorithms that will convert raw radar data from, say, an aircraft with an antenna mounted on the side that's circling a city, illuminating a large spot on the ground. And the goal is to convert that radar data into information about moving targets, moving vehicles, moving people, to recognize who they are, classify them, and track them over time. And this has a lot of application, obviously, in the military world, but also for civilian decision makers who have to know exactly those sorts of information in cases like humanitarian disasters and things like that.
I'm working with the Air Force Research Laboratories on several projects. One is the control of air-breathing hypersonic vehicles, which is the next class of space vehicles designed to replace the space shuttle for a different set of missions, and also on control and modeling of insect-like micro-aerial vehicles, again in collaboration with the Air Force Research Laboratory in Dayton, Ohio.
We use light to solve engineering problems, and one of the things that we work on is using MEMS, which are micro-electromechanical systems. They're chips. They're actually chips with little tiny moving parts on them that can operate mechanically, like mirrors in my case. So when you apply electrostatic voltage, you can make the mirrors tip one way or the other. And then I bounce light beams back and forth between a bunch of mirrors like I have over here. And the idea is you bounce back and forth, and every time they bounce, they hit a MEMS mirror, and then you tip the mirror one way or the other, and you switch the beam and do marvelous things. One of those things that we work on is using these light beams to steer a phased array antenna. So if you don't know what a phased array antenna is, that's okay, because we have classes you can take. But it's a big giant array of antennas, and when you add them all up, so that all their beams, which are very wide individually, when they add them up, they're all very directional. So when you go to the airport and you see that antenna that's spinning around and around to scan the sky, you don't want to do that mechanically. You don't want to have to grease the bearings, so you want to do that electrically. So we take the electrical signals that are going to the antenna elements, each antenna element, and we put them on light beams, and then we bounce the light beams back and forth to create time delays, and then the time delays change when the RF signal comes out of the antennas, each antenna in the array, and it effectively steers the beam. So you can take that beam and steer it around the sky without having to move any parts. Oh, that's very cool.
My name is Jessica, and I'm a senior specializing in circuits and control. And I'm a member of the OSU chapter of IEEE, which stands for the Institute of Electrical and Electronics Engineers. Being involved with IEEE has several benefits. You can network with professors and industry professionals while helping to organize our fall lecture series. There is the annual Student Activities Conference where you can meet IEEE student members from other universities, and there are regional lectures that you can attend where you can learn the latest developments in industry. The OSU chapter of IEEE is a great student organization that allows you to get to know your peers better while also gaining valuable leadership experience.
My name is Travis Case. I'm the social chair of Eta Kappa Nu, which is the electrical engineering honorary, and my job is basically to get everyone in the department involved in activities throughout the college and throughout the year. One of the biggest things we do each quarter is a donut social over in Dries Labs, where we get the faculty, advisors, staff, and students all together, socialize outside the classroom. Some of the benefits to getting involved in Eta Kappa Nu really include kind of unique opportunities with employers when we go and meet with them or host information sessions. Being able to get involved really close with the professors outside the classroom when they come to our activities or our quarterly socials. Being a member of Eta Kappa Nu has benefited me personally just by letting me really get involved in the department, meeting so many people and forming relationships that I wouldn't have been able to otherwise.
Hi, my name is Tayler Williams, and I'm a computer engineering specialty in electrical engineering. I'm the vice president for HKN, and as such, I run the tutor room here. We offer services to undergraduate students, tutoring in all of the first and second year electrical engineering courses. This is the tutor room here, and this is where we do a lot of our work. And it's really been a great experience for me to be able to share and give back to students that are working through the same things that I've been through in the past. I chose to join HKN because I was excited about being able to give back to the major that I'm in.
So Solar Education Outreach is a student group here at Ohio State, which I'm actually the president of. We went down to a school in Cotopaxi, Haiti, where we installed 4 240-watt panels, 7 lights, and 2 power outlets for a school that previously had no access to electricity. So at night, students who want to learn couldn't because there'd be nowhere that they could reliably go that's a safe place. So what we're aiming to do is provide a safe learning environment, kind of like a community center that anybody can go to at night. What we do is we take a team of 8 engineers down with us to go down, and so it's a service, learning, design, engineering project where both Ohio State students benefit and the people, the Haitians on the other side, benefit as well. When down there, we actually also work with students from the Haitian State University and University Carib coming together, so electrical engineers and other engineers together in order to implement this system.
You really need to go to office hours. Everyone's going to tell you go to office hours and you're going to be like, I don't really need to go. But really the teachers like to see that you're putting the effort in and get involved in something. Doesn't matter what. I mean, it can be something in engineering because there's tons of projects that you can do, or something off campus like barbecue club or something, but just really need to expand your horizons.
My advice to a new Ohio State student would be to get involved. The College of Engineering has over 30 different project teams ranging from solar to concrete canoe to eco-car to Baja. It just goes on and on. And something to note is that employers look at these, say, hey, this person's interested in engineering both in the classroom and outside of the classroom, really passionate about it. And they definitely take that into note when looking for, new interns or co-ops or even new hires, because you're getting that hands-on engineering experience that makes you a well-rounded person. Also, it's a lot of fun.
I recommend doing undergrad research. Just go to a professor that you're interested in that field. Ask him about research. A lot of our professors have ongoing research, and it's really, really helpful. I just went to Professor Berger because we keep reading about solid state and atoms and how they transit from one level to the other, electrons and whatnot. Well, you never get a chance to see it happen because it's not obvious to the naked eye. So I went to him and asked if there's anything that I could actually participate in to see how that theory comes into life. So I just went to his office and asked if he has any going research, and he said, yeah, sure. So I was working with him I'm working with him for past 2 semesters on the undergrad research. It really helps a lot. It makes you see the big picture, because when you take one class and then you have to take the other one that comes after it, you don't make a connection between what's going on unless you see it actually happening.
How to prepare to be successful in ECE or in engineering in general, I would say. Keep up with your math and science, and when you're studying for that final exam, study to remember it for life. Don't just study it to get through the exam. I wish I had done more of that, so there were a lot of things I had to go back and relearn that I should have known. I would have saved a lot of time, and I would have been better if I'd have learned all that stuff for real.
It turns out that in engineering we need all kinds of people. So we need people who communicate well. If you like to build things, of course, then it's definitely engineering. But in general, any engineering training that you get is going to prepare you to solve problems. So whether you go out and become a company CEO, or if you want to go out and do law, or if you want to go to medical school, the training you get in engineering, in problem solving, and just not being afraid of something that's difficult will just go a long way in making you really successful.
We hire a lot of Ohio State grads at MIT Lincoln Laboratory, and they do very well. They're able to take on problems that aren't well defined, and they can learn something new if needed, and really solve some tough problems, and also work on teams, that other aspect that I mentioned that's so important. And so I found that in the field I'm in, Ohio State grads can compete very well. I was very fortunate to go to school here, and I got a great education, and if I had a choice, I would want to come back here again.
My name is Professor Betty Lisa Anderson.